So welcome back everyone, and today we're starting our last module for the term, which is the geometry of 2D shapes, two-dimensional shapes. Alright, so let's dive straight in, and we are on page 68 of our workbook. So the first thing we want you to do, alright, and even if you just find a chance to do this at some stage, just draw a triangle. Alright, a triangle is a shape with three sides, three straight sides, and then cut it out. Alright, so cut it out with a pair of scissors, nice and neatly. Tear off the corners, all right? And we strongly suggest you tear off the corners, don't cut them off, all right? And then see if you can arrange your angles. There's the angle number one there. See if you can arrange them on a straight line. And we guarantee that you'll be able to, all right? And that is a demonstration. It's not a proof. It's a demonstration that the angles of a triangle add up to 180 degrees. We're going to teach you 5 important facts about triangles, okay? And the very first one is that the angles add up to 180 degrees. So we're going to just quickly share with you this little app over here. And we're just going to show you that when we drag these angles around, these corners that are around, and we sort of change our triangle, what you'll notice is that the angles always add to 180 degrees. This also is not a proof, it's a demonstration. All right. Okay, so the obvious thing is, well, how would we prove that this is true for every single triangle? Okay, and we're going to have a look at that right now. All right, how could we prove that? Okay, so what we're going to do, and we're going to ask you to do this in your book with us, we're going to label this triangle. Let's call it A, B, and C. All right, and now what we're going to do, and remember what we're trying to prove, okay? We wish to prove that angle A plus angle B plus angle C is 180 degrees. And all we're allowed to do is use what we know so far from our earlier module of geometry. Okay, and the trick to proving this, we're going to draw in a line here, all right? And we're going to draw it parallel with the base of the triangle. I'm just going to fix that line slightly because it's not really exactly where I wanted it. There it is. Okay, now I'm going to label these angles C1, C2, and C3. All right. Can anyone tell me, what do we know about C1, C2, and C3? What do we know? Well, we know that C1 plus C2 plus C3 is 180 degrees. Why do we know that? We've got to give a reason. We know that because those are angles on a straight line. Okay? But, and we're going to use the word but, what do we know about angle C1 and angle A? This angle in here, all right, what do we know about that angle and angle A? Okay, one of the things that I didn't do that I should have done is mark that this line is not just any old line, it's a parallel line. What sort of angles are those? Those are alternate angles. So we know that angle C1 is equal to angle A. All right? And the reason for that is alt angles, parallel lines. Okay? Now, what do we know about angle C3 and angle B? Yeah, that's right. Angle C3 is equal to angle B. So you might want to use a word like and angle C3 equals angle B. Exactly the same reason. Alt angles, parallel lines. So now what we're going to do, we're going to write out this purple line again, but instead of writing C1, I'm going to write angle A. And instead of writing, I'm going to write angle B as well. Instead of writing angle instead of writing angle C2, all right, I'm going to sorry, getting myself in a tangle here. All right, so what we now know, okay, we know that, sorry, I'm going to write this line out again. Okay, but instead of writing C1, I'm going to write angle A, because C1 and angle A are the same. Instead of writing C2, I'm just going to call that angle C, which was the original angle of the triangle. Okay, that's this angle over here. And instead of writing C3, I'm going to write angle B. Okay, so just to make, and we've proved it. We've now proved the angles of a triangle add up to 180 degrees. But just to make it clear what we've done here, we have swapped C3 in this line over here with B, because C3 is the same as B. We've proved that. And we've swapped C1 with A, because C1 is the same as A. All right. Okay, so I see a little A1 there, but just A. All right. Okay, the next big idea is that if we've got an angle outside a triangle, we call it an exterior angle. And the thing with an exterior angle is that it will equal the opposite interior angles added together. All right, just be careful though, this is not an exterior angle, this one over here. All right, this is not an exterior angle. And the reason being is it's not a straight continuation of the side. This over here is an exterior angle. We've just taken the side of the triangle and made it longer. Okay, all right, so now let's see if we can prove this result. And what we're going to do, we know we've proved the angles of a triangle add up to 180 degrees. So let's write down some stuff here. Let's call this A, B, C. Really important that you get this down. We're going to call that angle C1 and the angle C2. All right, what do we know about angle A plus angle B plus angle C2? What do we know? We know that they add to 180 degrees. Why do we know that? Angles of triangle. That's all we need to write, angles of triangle. The full thing is actually angles of triangle add up to 180 degrees. Okay, but what do we know about C1 plus C2? What do we know about C1 plus C2? Look where those are. All right, C1 plus C2 is also 180 degrees. All right, angles of triangle. So if we look at these two lines that we've got on the screen here, they're actually exactly the same, but this here is replacing this here. Okay, so we've got two things that add to C2 to give us 180 degrees. Those two things have to be equal. So therefore, angle C1 is actually equal to angle A plus angle B. Right, we've proved it. What have we used in proving it? We've used angles of straight line, which we knew already, and we've used angles of triangle. And this is how geometry works. We keep building and proving new results using results that we have already proved. Okay, important fact number 3, and this is really more to prepare you for some maths later on, but a really big idea is that if we've got a triangle, the biggest side will always be opposite the biggest angle. So if we look at the three sides, we've got 12, 11, and 8. The biggest one is 12. It will be opposite the biggest angle. Look at the angles. We've got 41, 65, and 74. They add up to 180, obviously. Right, if we look at the smallest angle is this little angle, 41 degrees here. The smallest side is 8. They will be opposite one another, always. The smallest angle has to be opposite the smallest side. The biggest angle has to be opposite the biggest side. And the middle-sized angle has to be opposite the middle-sized side. It's impossible for it to be any other way. All right, this one's quite interesting. Okay, no one side in a triangle can be bigger than the sum of the other two sides. All right, and I think we can see why. So, for example, it's impossible. We can't. I'm just going to write this down. We cannot have a triangle. We cannot have a triangle with sides of 3, 4, and 8. Okay, and we'll see why now. Because let's just draw the 8 here. Okay, here's 8 units, okay? Let's say these are all centimeters, 8 centimeters. Right, now if we think about our 3 centimeter side, kind of coming over here, all right, 3 centimeters, and our 4 centimeter side coming over here, all right, they actually can't join up. They're not long enough because together they are shorter than 8. So what we need is we need the longest side. The longest side can't be bigger than the sum of the other two sides. All right, that's a bit of extra stuff that doesn't often get taught to grade 8s. Okay, but obviously we want to teach you everything, and it's interesting and important later on. All right, the last one here, okay, and we're not going to necessarily spend time on this, but what if you take a triangle, any triangle, and you make a whole lot of copies of it, then it's possible to tile. The fancy word is tessellate. It's possible to cover a whole area with that triangle, just that triangle, with no gaps and no overlaps. Okay, we'll try and demonstrate that for you. Ideally, you should cut out a triangle yourself, make a whole lot of identical copies of it, and then see if you can do it. But let's just see if we can show you how that looks. Okay, so let's have a look. What we've got here, we've got a whole lot of triangles that I've drawn, and I'm going to see if I can do exactly what I told you that we could do, and that is to kind of cover a whole area without any gaps. Okay, so I'm just sort of going to see if I can kind of bring that one in over here somewhere. All right, then let's get this one in and see if it will fit in kind of over there somewhere. All right, and maybe this one and see if it'll fit in kind of over there somewhere. All right, and I'm going to make a copy of this one, and let's see if we can, let's see what, maybe we might have to sort of swing it around and fit it over there somewhere. All right, and then let's get another copy and see if we can fill in that gap there. All right, so fill in this gap over here. Okay, so that looks like it could fit in there. And then let's maybe make a copy of this one and see if it fits in there. All right, and so we can carry on. And we can actually cover the entire plane with these triangles, okay? This, I'm probably going to have to turn around to something like, let's see if that length fits in there. All right, and this is possible with any triangle, okay? If you don't believe us, cut out some triangles and see. But you can actually fill the whole plane. Right. One of the reasons that this works with triangles, okay, is that if we think about the angles of this original triangle, over here, if we look at it, we've actually got one of each of the angles twice. Okay, I'm not actually sure exactly which ones are which, but for example, we've got a green angle. Maybe these two angles are the same, I'm not sure. Yeah, they look like they probably are. And then maybe a red angle over here. All right, and what do a green and a red and a black add up to? They're in the triangle, they must add up to 180. And we've got two of them, and that fits into 360 degrees. Okay, so it's always possible to tile triangles. Okay. All right, that's really more just for interest. Okay, now let's tackle some questions. All right, so what we want you to do is we just want you to work out the remaining angle in each case. Right, and we're going to give a reason. We always give a reason. Okay, when we add these two together, we get 120 degrees. This angle here must be 60 degrees. How do I know? All right, angles of triangle. they must add up to 180 degrees. This one here, these two add up to 140. All right, this one must be what? What's the supplement of 140? It's 40 degrees. Reason, angles of triangle. We're going to ask you to pause the video, and we're going to ask you just to finish the rest. Let's go up to the end of page 74. All right, and then we'll go over them quickly. Okay, so 52 and 52, 104 degrees. What's the supplement of 104? 76 degrees. What's our reason? Angles of triangle. Right, we always put our reason in brackets. 53 and 79, that's 132. 132, 180 minus 132, 48 degrees. Angles of triangle. Okay. Now, what do we know about the exterior angle of a triangle? We know that it adds to the opposite interior angles. So this angle over here, all right, they're asking us to find the shaded angle. This angle over here is going to be 76 plus 52. It's going to be 128 degrees. This time, we're using exterior angle of triangle. All right, now, this one, and I'm actually going to, I'm going to call this x, just to give it a name that I can use in an equation. This time I'm going to make an equation. X plus 71 must equal 143. And the reason for this is that this is an exterior angle. It must equal the sum of the opposite interior angles. So exterior angle of triangle. Now we need to solve this very simple little equation. And when we subtract 71 degrees from both sides, we're left with 72 degrees. Okay, right, on page 74, we've got some variables now. So I think what we need to do is write down an equation. That'll give us a mark. Give a reason, that'll give us another mark, and then get our answer. All right, so here we've got 2x plus 4x plus 3x, and all of that must come to 180 degrees. What's our reason? Angles of triangle. Right, 2 plus 4 is 6 plus 3 is 9. We've got 9x is 180 degrees. Let's divide both sides by 9, and we get x equals 20 degrees. Okay, this one. Well, we know that 6x plus 90 degrees plus 2x plus 10 degrees, what must all of those come to? They must come to 180 degrees. What's our reason? Angles of triangle. Let's collect our like terms on the left. 6x and 2x, 8x. 90 and 10, 100. So 8x plus 100 degrees is 180 degrees. Let's subtract 100 degrees from both sides. We get 8x is 80 degrees. Let's divide both sides by 8. Final answer, 10 degrees. As always, guys, if we want to check, we can actually check. This would be a 60 degree angle. And if x is 10, this would be a 20 plus 10. This would be a 30 degree angle. Do they add up to 180 degrees? Yes, they do. Is it right? Yes, it is. Okay, what sort of angle have we got here? We've got an exterior angle. What do we know about exterior angles? They add to the sum of the opposite interior angles. So we know that 140 degrees is 3x plus 4x. We need a reason. Exterior angle of triangle. Okay, so we know that 7x is 140 degrees. What should we do to both sides to get x? We should divide both sides by 2. X is 20 degrees. Okay. Right, in this one over here, this one's a little bit harder because it's got variables everywhere, but this is an exterior angle, and we know that 4x minus 19 degrees must equal 2x plus x plus 18 degrees. The reason for this is exterior angle of triangle. Right, now, on the left-hand side, we've got 4x minus 19 degrees. On the right-hand side, we've got 3x plus 18 degrees. Okay, now I'm going to do two things at once here, and we hope it won't freak you out, but we're going to subtract 3x from both sides. That just leaves us with x. On this side, I've still got a minus 19, which I don't want, so I'm going to, at the same time, I'm going to add 19 to both sides, and 18 plus 19 is 37. Okay, and there's our final answer. Right, what have we got here? Well, we've just got angles in a triangle. What do we know about angles in a triangle? They are supplementary. They add up to 180 degrees. So 44 degrees plus 2x plus x minus 10 degrees is 180 degrees. Let's collect our like terms. We've got 3x minus 34 degrees. Sorry, 3x plus 34 degrees is 180 degrees. Okay? We're going to subtract 34 from both sides. When you subtract 34 from 180, you get 146 degrees. Okay? And when you divide both sides by 3, it doesn't actually work out exactly. All right? 1 plus 4 plus is 5 plus 6 is 11. 11 is not a multiple of 3. So 146 is not divisible by 3. We can just write our answer like this. 146 degrees divided by 3. All right, it's a little bit less than 50. It's about 48 degrees or something. Okay. All right. Yeah, it's actually 48 and 2/3 degrees. Okay. So I'm just checking my working there to see that I haven't made any careless errors. I have done one silly thing and one problematic thing. I've left off the reason. The reason for this is angles of triangle. Okay, and the last one we're going to do today, let's make an equation here. P plus 40 plus 56 must equal 180 degrees. Reason, angles of triangle. So P plus 96 degrees is 180 degrees. Right? So we're going to subtract 96 from both sides. And what we're going to get is we're going to get 84 degrees. All right. When you add 84 and 96, you get 180. All right. So before the next lesson, we want you to try the next couple of questions. In fact, you know what? Well, let's just quickly... No, let's stop there. Try the next couple of questions. It actually should be question number 3 and number 4. All right. And we will see you next time. Have a great day, everyone.